Hey everybody, it's Martine Paris for Pocket Gamer here live at Collision in New Orleans, and I'm here at the GE booth. Isn't this so cool? So I have no idea what I'm looking at, but it's just like mesmerizing. Because check out the rest of the show floor. It's like just all concrete. You got all the startups back there, and then all of a sudden GE comes with this like space age thing. And we're right by center stage, and I'm being joined by Carl Bernoski. He is in the design group at GE and his colleagues, and he's going to tell us a little bit about what we're looking at. Hi.
So, hello, my name's Carl. She just introduced.
You want to come and join us over here?
And
a nice visual.
What we're looking at here is a graphical animation that represents the concept of the digital twin. And so to answer what the GE digital twin is, I'd like to bring in Mr. Todd.
Why don't I bring you in the frame?
All right.
Yeah. Hello.
Hi, how are you?
Yeah, good. So we're live on Periscope, and what are you guys doing here at Collision? What is this that we're looking at?
So you are looking at a gas turbine. It's about a 250 megawatt machine in this case. It's found in power plants, so it's part of the big machines that we make that help power entire cities. And what you see at the bottom is the physical machine itself that we make and we know everything about. And
that's cool. Do you guys see that? That's a physical. No,
it's an HA gas turbine.
Oh, all right.
Biggest gas turbine in the world.
Right, and the world's most efficient.
But it's a projection of it.
Right.
A projection, right.
Yeah.
That's the physical representation, and then there's the digital twin. So basically, all the data that we collect, and there's lots of sensors in this machine that measures the condition of components. It looks at the pressures and the conditions of the turbine itself, and all that information is collected, and we use it to create a digital twin or a digital profile of that machine. And we're doing this across all of our products because what it does is it's giving us insights into how that machine's going to operate that will allow us to help predict its operation going forward. So for a customer, to take that machine and have to do maintenance on it, you would prefer to have it be a planned event. You don't want your turbine to unexpectedly break down and you have to take it apart and take it off service offline.
Right.
So these are $100 million machines. So what we can do is you might have a scheduled maintenance on this machine, for example, and you're going to replace 3 parts on that machine. But maybe the twin has detected that there's 5 other parts that also need to be repaired, that they're not going to break down next week, but in the next month you could have some issues with it. So the twin will tell you, hey, maybe you should replace those parts as well. And
what's interesting is wouldn't the data just be transmitted directly from the sensor straight to the computer anyway? Why do you need a digital twin to do that, other than a beautiful illustration?
Well, so digital twin, so it's
what
operated.
Is this telling us 3D wise? Is it telling us, giving a visual representation of exactly what's wrong on the grid?
I would say think of this machine now as almost like a person. It's a living digital model. So imagine your health records.
Yeah.
And your health changes over time, your condition changes, so every day it's a little bit different as we get older. Same thing with the machine. It gets older, parts get older, parts need to be replaced.
Right.
So this is a living model that we can call upon to help us, help our customers manage them much more optimally than they could be managed before.
This is great for industrial internet, like being out on an oil rig in the middle of the ocean where you can't get to and see it, and then you can see where the parts are wearing down and you need to send out a pretty quick. You can also do this on a fleet of airplanes, I would imagine, right?
Yeah, jet engines. We do the same thing for jet engines too. Wind turbines.
Yeah.
We have wind turbine farms, and Carl will know this better than I would. It's you might have a fleet of say 20 wind turbines, but each has a twin, and those twins talk to each other. And we just by making these turbines more intelligent, and we have controls on the turbines that react to what the data is telling them. So if wind gusts are coming in a certain way, one of the turbines might say, I need to change the pitch of the blade to lessen the stress on the tower. But basically, out of all this interaction, this intelligent interaction we can enable through digital twin, you can get up to 20% more output from your wind farm than you could get before.
What are you hoping to get out of Collision?
I think just to educate people that GE is big in the digital space. It's also to educate people that the next frontier of the internet is the industrial internet, and it's this Internet of Things that a lot of people are talking about. This is really a great example of how that Internet of Things is taking shape, where you have machines that power the world. In this case, we have machines that help airplanes fly, locomotives that carry freight and goods. All of these machines are being brought into the Internet of Things so that we can manage these assets in much more optimal ways than we could before. And it's really the next frontier of where the Internet is going to provide value. It's really in the industrial space, and that's why we're here at Collision, is to really spread that message.
Awesome. Well, how are you enjoying the conference so far? What party are you going to go to tonight?
I haven't even I haven't thought about the party. I've got if you have any recommendations,
well,
I'd
there's
be open
Night Summit, of course, open to all attendees.
I'll have to stop by that. I love being in New Orleans. We love being here to showcase this beautiful Turbine, but and it's just a great place to be.
It is actually a really beautiful display. Thank you so much, Todd Alhart. I'll make sure that you're on the tweet as well. And thank you, Carl.
Nice to meet you.
And beautiful. I'll just pull that, guys, so you can take another look at this. So pretty, right? All right, guys. I'll see you in a little bit. Next up, Sports Stage.